In this lecture we are going to see what do we mean by the movements. As you have studied in the statistics in 10th class or 12th class, that is how we take the mean, how we take the mode, median, how we take it, that is the related terms to that study. Here we are going to study what do we mean by movements. So movement may be the mean, movement may be the square mean, movement may be the third order mean, movement may be the fourth order mean, movement can be of any nth order. So here movement, if we talk about the movement of first order, that is the simple average, we can say arithmetic average. So if we say that is x average, here we are taking this example and values, that some practical has been conducted, some experiment has been conducted, where you are getting a value over n repeated times. That is we are getting that value n1. Means when an experiment is conducted for n times, that time you are finding that some value, that is we have here taken, that is x1, and that you are getting at n1 times. Another value you are getting n2 times, another value you are getting n3 times. Likewise, if you get the values of xm value nm times, then all the values we will add them and then we'll divide by those number of observations point, total number of observations point. So likewise we take out the average. Here we are indicating x average, we have written n1, x1, n2, x2, n3, x3 plus dot 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 n1 m nm xm divided by n. Here if you see, if you divide this, if this is very large, then you can divide it individually, that n1 divided by n, n2 divided by n, means n1 divided by n x1 plus n2 divided by n x2 plus n3 divided by n x3 plus dot 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 nm divided by n into xm. So likewise if you can write, so if you take that 1 by n and then you can write that summation of these quantities nk xk over k is equal to 1 to m, then this is average. Where if you see that n1 divided by n, that how many times you got that value, that number of times divided by total number of times, this is nothing but the probability. So you can write it in terms of the probability also, that if you write these terms, that you can take it nk divided by n, though this will be the probability of nk, or okay, probability of xk, that how many times you have got that probability. So this average again we can write and in this form, that is that we can write it in this form, that we can say that is E of x, that is expectation. This mean can be written with the help of writing like this. This is the one of the terminology, that is E of x is equal to x bar. This is average value, and that is k is equal to 1 to m. That if we say that n1 divided by n is equal to p of x1, and n2 divided by n is the p of x2. Likewise if we say that x3, the probability of x3 is equal to n3 divided by n. So likewise we can have this probability and we can replace it here, that is nk divided by n, that is the probability of xk. This can be written, p of k can be written as pk, means that is p of xk. That is the frequency function, we can see. So here again the frequency function multiplied by that particular value, if you take over this range k is equal to 1 to m, then we can find out the average. Similarly, if you take the second order average, that is square average, then you can take that. So again you can simply write that the sum, that is n1 x1 square plus n2 x2 square plus n3 x3 square plus dot 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 plus nm xm square divided by n. Here also, what you have done, you have conducted an experiment, you got some result, that is x1 and x1, x2, x3, x4, but x1 has been observed for n times, n1 times, and x2 has been observed for n2 times, and xm value has been observed over the conduction period of the practical or experiment, that is nm times. Then that value which you have observed, if you take the square of those values and multiply it by the number of times, corresponding number of times, and then you add them and divide by total number of observations, then you can get the second order movement, or we can say average of that square average of that experiment values. So next, if you take nth order movement, similarly you can write x nth order movement. So here we can write the pk x to the power n x. Here we can write that is x e of x to the power n is equal to k is equal to 1 to m summed up over this range. That is the values of pk, means that particular frequency function of that particular value, and multiplied by that valued square, valued nth orders. So likewise we can say that is this nth average we can find out, okay, pk xk to the power n summed over k is equal to 1 to m. Likewise we can find out the nth moment also. Here if you find out what is the probability density function, so we can understand it, probability density function, this is again it there that probability distribution function was for the discrete quantities, discrete variables. Here the values were discrete, x1, x2, x3, x4, x5, x6, they were discrete. If at all, if we take this probability distribution function over a range, and over that range, if we are taking over a particular range, we are taking, that is we have taken probability of x minus del x by 2 to x plus del x by 2, over that range is del x. So if you write it in this way, that p of x minus del x by 2 less than or equal to x is less than or equal to x plus del x by 2 divided by del x, when the del x is very small, it tends to 0, then this term can be indicated by the probability distribution, probability density function. So probability density function is the differentiation. If we can say the probability density function is the differentiation of the probability distribution function over a particular range. So that again we can write that probability distribution function in terms of the probability density function. So probability distribution function, we have taken p of x1 to x2 of x can be written as the integration of p of x dx over a range x1 to x2. That range we have defined it here. So again what we are doing, we are integrating it. It means we are continuously adding the probabilities density functions. Then we can get the probability distribution function. So probability density function and probability distribution function both are interrelated to each other. So here if we take that range of probability distribution function minus infinity to infinity, that random variable assumes its values minus infinity to infinity, that time we can say that is equal to 1. And it follows that if it is equal to 1, then minus x, integration of that p of x dx over the range minus infinity to plus infinity, that also will become 1. So this is about the probability density function and the probability distribution function, both are how they are related. Okay. Oh, thank you very much. Read it and will take another lecture for the same. Thank you.